Hey, morning, guys.
Morning.
Okay, let me share my screen. Yeah, let's wait for 2 more minutes for more folks. Okay, so let's get started. Can you guys hear me?
Yeah, I can hear you.
Okay. Yeah, I think Zhitao is got disconnected, but yeah. I just want to discuss some the HDFS first. So I sent out a couple patch. I think we have a GR number. I forget where it is, but we have different way to support HDFS. Basically, we want to support like both cases, no matter including either tarball or image layers from HDFS. So I think it is possible to maintain a Docker registry which is serving HDFS schemes, which means like Mesos talk to HDFS to get the manifest, and then after getting the manifest, Mesos talk to HDFS to pull down each of the layer tar. And there are 2 ways to fetch image right now supported by Mesos. One way is to just download the whole image as a tarball and then regard the whole image as a tarball. Can you guys see my screen?
Yeah, we can see it fine.
Oh, okay. Yeah, so currently there are 2 ways. one way is have image, support image as a tarball. Another way is like talk to Docker registry, get the manifest first, and then after we get the manifest, we know which layers we should download, and then we pull down the layers. So I think both way we could support with HDFS. So for now, we focus on the image tar first, because I don't know how many people using deploy Docker registry on HDFS. I'm assuming not too many people just talk to HTTP or HTTPS registry, no matter local registry or remote registry. So we want to adjust, because tarball it might be a big file, and it can come from different skins like HDFS, S3, and etc. So initially we want to support HDFS first, and for the interface we have different options. So right now we rely on an agent flag, Docker_registry, to specify where the image comes from. If it started as /, it means a local directory. We're gonna pull the image from a local tar, and otherwise we will try to pull the image from a remote registry. And another option is we have a URI, because the image is a user-specified content, and we could have an optional URI in the protobuf, no matter in container info or the image protobuf. We could specify HDFS URI and specify where the tarball comes from. So, and if it is set, we pull that as a HDFS image tar. Otherwise, we do what we used to be doing. So both ways sounds good to me, and I think eventually we want to have a URI specific image interface. But that's what OCI currently doing. I think in OCI image spec, they allow an optional URI if it is set. So the run C gonna just pull the image from that URI. But right now, I am still hesitating to introduce this new API because we do not support OCI yet. We don't know what's the best way we support OCI for now. For example, we could introduce a new image store to support OCI, and then which means we have to introduce to do some refactoring, unify two-factor, and unify the cache, so that we can have a unified artifact store to manage all the user-specified content in one place. So here, the user-specified content is image plus the artifacts specified by URI. So if they are content addressable, so we should have a unified data structure to maintain those contents. And that's one way to support OCI. Another way, it is to introduce a new containerizer, and which leverage either container D or run C. If we use run C, it means we have to do some refactoring and then have the image pooling codes refactor to the new containerizer. So both containerizer rely on the same code, the URI fetcher to pull image. And then we rely on run C to start a new container. If we have a container, so those are the decisions we do not decide yet, because we start to have more concern. Right now, we have more and more container runtime in different community and different companies. They have developed their own runtime. For example, right now we have run C, we have Kata container from Hyper and Intel, and then some people will announce the gvisor recently from Google, which is a sandbox container. And NVIDIA have their own runtime, and Nomad has their own runtime. So for different container runtime, it seems to me they have different set of features. So all of them, they can launch container, but they have different concern and features. So some of them focus on security, some of them could do more on networking. So I start to think about like, maybe in the future, we should have a containerizer that we could allow user to specify different runtime. What's the runtime they want to use? And then they could rely on that runtime to do whatever specific they would like to achieve. And Mesos unified containerizer is gonna be refactored as a standalone container runtime. And it will be default runtime for Mesos, but user could still rely on any other runtime they would like to use. And we only maintain one single containerizer on Mesos code base. I think that might be the goal we want to achieve in the future. And so that's one reason I put another agenda item here to discuss about more container runtime here. They are all related, and they're related to how we support image tar for image tar archives from HDFS. So so right now the thing stopping me to introduce more API are the concern that we might have to do more design for the other OCI and other run C support in our API. So I don't know what they are eventually. So I am proposing to support HDFS by by the current API we have, rely on the agent flag Docker_registry. And if it is started as HDFS skin, we just pull it from HDFS server, pull the image table from the HDFS server, and then Mesos untar it, and Mesos will cache the image, will cache each layer. And if the image is already cached, so if the user uses the image again, it will not download the image from the HDFS server again, because we maintain a unified cache. This is called metadata manager in Mesos. So there's some limitation on this. It means like when the user specify a HDFS based server, they have to put all the image tar under one directory in their HDFS. And if they rely on HDFS image tar, they could not use local tarball or remote Docker registry. This is kind of like a big limitation. And once we have a better idea how we should support OCI, we will definitely refactor this part and allow user to use different source, for example, the local tar, HDFS tar, and remote Docker registry. By the API level, they can specify whatever they want. So I would like to hear what you guys think about on.
Hello, can you hear me?
Yeah.
Sorry, I missed the beginning. My network was broken. So I feel like there are multiple problems here. One is supporting multiple runtime. That is one. The second is because we need to support multiple runtimes, we might need to support different image formats, container image formats. And the third problem is how do we serve these image formats from HDFS? Am I reading the problem correctly?
Yes, correct. And basically, the first one, it is a small problem. Depends on how we support HDFS. Rather than now, we should introduce more interface, more API. And the second two, for different container runtime and different container image formats support. These two are they might be something we gonna do in the future, and all these two, they are related. So touching each part, they rely on the other two.
So one quick question about, so I used to be familiar with the Docker image format, but I have not looked at the OCI for a while, and I don't know what gvisor, things like gvisor use, but do they all use the same content addressable format? Like their image spec, are they all similar to Docker image and being SHA-56 or something like content addressable?
I don't know about gvisor yet, because they just announced it, and I believe there are a lot of issues yet. They cannot run a lot of image type like Spark, like Cassandra, like some database image. They are not supported yet.
Okay.
But for the OCI default runtime, run C, they are content addressable based.
Okay. So my feeling is the third problem is a little bit more self-contained. So we can maybe we can start discussing that one, like the serving from HDFS. First of all, there is a web interface of HDFS. Have we looked at that?
Yeah, we did go through the HDFS interface, but the discussion here, it is like because if we want to support multiple image source, so from different source, it can be from either HDFS, HTTP, or any other.
I'm not sure about that, because in my opinion, all these image formats translate to content addressable files that then tar zipped into a particular format. There's actually some pretty well defined. That is actually a pretty well defined interface, and I think my feeling is only serving through HTTP using web HTTP or something may be a good enough workaround for a lot of people.
Well, another way to implement this is to write a local Docker registry server which backs onto HDFS, so you abstract it completely away from this.
I'm going to get there actually. So one project my teammate has been working on is to build a P2P distribution engine for content addressable binary artifacts, no more, no less than that. And they broken that into roughly two logical components. One is the core part of P2P distribution. The other is using HTTPS as the source of the P2P distribution system. However, for their clients, we have been saying that the only supported API on the client side is HTTP serving these content addressable binary artifacts. So we kind of say because the client actually only talks to exactly a local proxy, which performs all the P2P distribution under the hood. It kind of hides all the complexity of that work and behind that proxy, and it keeps the client pretty clean.
So the component you guys building JetHouse, so the content here, they mean both artifact and image.
Yes, if you, I remember Docker image itself, just the Docker image artifact itself is one content addressable file, a small file.
Yeah.
When we read and expand it, I think it has a lot of metadata, but and then all the layers, which again is all the content addressable files in the same system. So it's like two rounds of HTTP get, HTTP download through HTTP, and that's it.
Yeah.
Have you seen the Alibaba project around this?
Yes. I think the project we started later than them. We are pretty close on code completion when they announced the project, so we decided to finish our things. I think we plan to open source it sometime. We just haven't got to it yet. Yeah,
basically, I talked to the creator at some point last year. It is called Dragonfly, right?
The Alibaba one.
Yeah, it's called. It is
called.
It is called Dragonfly, and they asked me if we are interested to like plug in that component to make it to support it on Mesos. So we used to have 2 years or 3 years ago, we have a Jira to support P2P content fetching. So there's an epic about that, but I don't think it is not prioritized by Mesos here. But I think there are many other companies are interested on that. I think we should like have kind of this thing support on Mesos, no matter by the third-party project or natively by Mesos. So we should support like P2P and content adjustable fetching of user-specified content.
So the main problem with the main like technical problem with like proxying everything through like a Docker compatible HTTP interface is that when you do that approach, you always have to pull down the whole archive. I guess you probably have to do that to unpack it anyway, but when you're building a container, you typically don't need most of it. So you can do better if you have better understanding of the data you're pulling down.
Sorry, James, are you suggesting that you can only download a subset of the root file system of the container?
Yes, I'm suggesting that you can build a storage system which populates data on demand, but that you can't do that if you have to go through a HTTP Docker registry. Which isn't to say that an HTTP Docker registry isn't like an improvement.
No, you cannot. But I don't think the current file system-based image provisioning can support that well either. Especially if you're provisioning the system on the real file, the local file system.
Yes. Yeah, I think you're right there.
So, Zhitao, I have a quick question for the project you guys currently building.
Yeah.
So you guys could support HTTP. You guys could support HDFS or HTTP, and then their P2P pooling. How do they plug into Mesos, or you guys use that for the other project?
So they put a thin layer as a Docker registry. So exactly like what James described, we have the local P2P agent. I believe the local P2P agent has an extra interface which acts as a Docker registry interface. So all our Docker images are then translated into localhost fixed port. So we just pull all the images through there.
Okay, so you guys do P2P fetching between your own layers to deliver each layer as a tar, and then serve them in the local registry, and the local registry runs in each of the agent. And Mesos rely on Mesos registry pooler to pull out the manifest and then download each of the tar from local.
Yes.
And consume the image. Yes. Makes sense. Makes sense to me.
Yeah. I believe all the traffic are standard HTTP, so we believe we don't need to modify any code in Mesos right now. Although I think I have 2 patches in our queue try to improve the monitoring of this stack to understand the latency part.
Yeah, we should have this on. We should have this discussion earlier, and because people have been discussing like the P2P fetching for a while on Mesos, and I believe at some point when we introduce the unified artifact store, we have to unify 2 fetcher, and maybe we could introduce a P2P fetching in the in the unified fetcher with a unified cache, so that we could. Yeah, at that point, I believe for the P2P image fetching will be much more easier. But it's a very good point to move.
Yeah, another comment I'd like to make is just based on my interaction with that team, I just provide some. Sometimes I give design ideas, but I don't work on it directly. But given my impression with their work, I think P2P, a lot of optimizations and improvement on P2P are very organization specific and related to both use pattern and the actual physical network fabric of the organization using this. So my feeling is making this pluggable might be better than build a built-in one. In Mesos, what I mean is, my feeling is.
I understand. I understand. And we have to, when we decide, if we decide to support our Mesos.
Yeah. So for example, one real challenge we had is how to optimize, how to control the total throughput between public cloud and private cloud in our environment, because our system actually needs to deal with both. We run the same system both we plan to run the system both on AWS as well as our own data center. But the network between them is actually from packet perspective, the most expensive part in our system. We want to control that part.
Zhitao, in your environment, is the origin for the images inside the cluster, or is it outside the cluster?
I don't have correct answer for this yet. I think they were quite quick, still fast, iterating pretty fast on this one. My impression is they need to support both S3 as well as AWS as origin. But I don't know how they deal with the consistency between two systems yet.
So for our use case, one of our principles is that we want to have all the images, all the user task artifacts, which can include images, to be reliably stored within the cluster. So whereas we could use P2P for distributing things across agents, but we'd want also to have some guarantee that the whole content, all the content is reliably stored within a single cluster, and we don't have to reach out to S3 or some other external store.
Yes, I think that's also our requirement. All the content will be safely stored on some kind of, consider that cold storage, HDFS or S3. Actually, I think that's what happens behind the upload path or the dog pool. All the pool ended up, I believe our system first ensures that all the content are safely stored on the either S3 or HDFS. And after that, there might be optimizations to speed up the distribution. And then, but we hope most of the actual distribution to the agent happens through P2P. There's a lot of optimization the team is doing, which I'm not familiar with the detail. I just know their high-level direction they're moving.
I think we need on Mesos side. I think I need to spend more time on investigation on different P2P protocol and different for different protocol. What's the requirement and configuration they need, and basically I believe it might be possible to have some universal support and with different options for user to plug in different components. But we could discuss the P2P fetching in the future once we get to the adjust those fetcher tag and decide a new fetcher in Mesos code base. And for now, James, do you think the HDFS support based on the Docker registry, is the limitation cannot fulfill your requirement?
Honestly, I don't know.
Okay.
The HDFS was something a bug I filed for us like a year ago, and I never seriously investigated it.
Yeah. Okay. I think eventually we have to somehow support content addressable fetching with a unified cache on Mesos side, and if we introduce more runtime as a second separate problem, we may not rely on the third-party software to pull image, because we already have the support. We don't need duplicate things, which means if you want to support OCI with different runtime, we may not support containerd. We may just use a lightweight run C as a separate containerizer and then still pull the image by ourselves. So I think for now, if we rely on the agent flag, it will not break any other parts of Mesos code, and for any Mesos user, And we could introduce new API anytime we want to support flexible image source, no matter from HTTP, HDFS, or either tarball or registry. And at any point, we understand how the OCI support API, OCI support should looks like. Once we have to decide, we could refactor this part. So there might be something we're gonna be doing for the HDFS, and I will send out an email. I will send out an email later about what we're gonna do with the HDFS.
Thanks. I'll try to talk to our team better to see whether we can speed up the open source process here. So at least we can have a reference implementation about how this would work. I think we already deployed that to a couple of pretty large clusters, and they're working very well.
Okay, yeah, that sounds good. And there might be another competitor for Dragonfly.
I think if Dragonfly was open source 2 years ago, we might just take it and modify to use. But we already I think we actually reached the code complete when we heard of Dragonfly. We have not started to deploy it, so we decided to go with our own at that point.
I guess you guys started almost at the same time, and they just open source earlier, and they are still building it, as far as I know.
Yeah.
What's
I think the project is called Kraken.
How?
Huh?
Pelican.
Kraken, Kraken. Yeah.
Okay.
Yeah. I think everybody is pushing their team to write end blogs as well as looking at open source.
I see.
Yeah.
Okay. So yeah, and we can continue the HDFS discussion in the email thread, and I will send it to the dev list. So for the second one, I think this is more important to the containerization on Mesos. It determines what the future, what it gonna looks like, what the container runtime how the container runtime gonna be supported on Mesos. So as far as I mentioned, in the past half year, I see a lot of other container runtime become popular. Previously, people just use Docker, and then Mesos 2 years ago, Mesos had unified containerizer with the own container runtime rely on Linux features. And then different other projects like Nomad, they start to announce their own runtime. So, and then Kubernetes work with Docker to open source container D, and then Docker contribute the runc to OCI community. So which means they all rely on runc as a container runtime. And like 6 months ago, I heard about the project of Kata container from Hyper and Intel. So basically, they announced that as a lightweight container. Basically, it is changed from the current VM, and then they move some component out from the VM, and then they claim it as a container. Basically, it is something between container and VM, but it did has some VM features, like it can isolate some resources by hardware, which means it's more secure. It has all the security, most of the security features from VM. So that's what they announced from their repo. And then yesterday, I believe it's yesterday, Google just announced the gvisor, which is a sandboxed container, and they achieved the security by some other way. By simulating the kernel, and then they rewrite some kernel feature by Go, so they could achieve some security Go in gvisor. So people consume gvisor by by Docker by run C, I believe. It is supported by run C. And they can specify different runtime by dash dash runtime or dash dash container runtime. And it is plugin, it is configurable via both Kubernetes or Docker. So they can specify what type of container runtime they would like to rely on, and the runtime compatible with those platforms. So it means Kubernetes and Docker Swarm. And my concern here, it is in the future, we might have more and more container runtime. And different runtime, they can launch container process, but they might have different set of features for their own runtime. For example, some user, they really care about security. They might use Kata runtime or the gvisor runtime. And some user, they might have some storage-based features, and they might have some other runtime, and they might also have their own customized container runtime. So I would like to see like Mesos user have flexible options for different runtimes in the future, so that because it is hard to catch up with different support. Like we have been discussing about like a VM containerizer to support VM via KVM or hypervisor. But those, we are still in investigation stage, and it has been there for a while, but we don't have too many progress on that. So which means if we want to support more runtime, we might rely on the third-party software, which is not bad, which does not seem bad to me, because users have the option. They still have the default runtime on Mesos, and they have the option to use any other runtime they want. So the discussion here, I would like to hear what you guys thinking about support multiple runtime on Mesos, and how will we gonna support them, and will we make it compatible in one single containerizer? I think Jens and Jita, you guys might have some idea about this.
Yeah, I think the direction is great. I think I support being able to plug in third-party runtimes to Mesos. I didn't realize that the OCI interface this was so atrocious. In general, my experience is that execing commands is a terrible API. It will come back to bite you every time. The debugging experience is shit. The propagation and error handling experience is shit. Like just generally trying to interact with these things as an API is painful and disgusting and horrible. That said, if this is the thing that the industry is doing, we should do it too, simply because people need it and people want it, right? So that's fun.
Sorry. Is OCI runtime a fork exact interface?
Can you repeat that? Yeah.
Yeah, could you repeat that? We cannot hear very clear from you.
I thought these are gRPC interfaces. But I guess that's CRI.
Yeah. So if I remember correctly, Containerd rely on gRPC, and I'm assuming run C is also rely on gRPC, but it is not a problem for Mesos. We already have the gRPC support in bprocess, so we can leverage the gRPC with to commute with different components very easily. It should be very simple.
So I think my other concern is around the Mesos API. API concepts around task info aren't going to necessarily map well to OCI. I think we'd probably need to think carefully about how we do that, and how and whether we can map concepts which are specific to a third-party containerizer through the Mesos API. Like, I mean, one of the reasons why you might want to use a third-party containerizer is it supports a specific feature you need. But in that case, you probably also need a way to tunnel some configuration through the Mesos API into that container. And it's not clear to me how we would do that with the protobuf API approach.
Yeah. That's something people have to figure out during design, because I totally agree on the API mapping, because I guess there might be some feature Mesos have, but the runC may not have in the runtime, and there are maybe more features runC support, but Mesos don't support those features yet, and we have to. And there are some features maybe both of Mesos supported, Mesos API supported, and runC supported, but they might not be compressible. So we have to deal with those each of those cases carefully, and maybe initially we could support some very basic functionality, and then in the future we could add we can add each feature step by step to the API. So it will be more. It will capture more eyeball on the dev list, and people could get together to discuss whether or not the API makes sense. That might be something we could move step by step.
Yeah, just in general, I think I agree that supporting multiple container runtimes is the right direction for the project.
Yeah. Sounds good. So Ian and Zhitao, do you guys have more comments on the support multiple?
So I feel like it would be nice if someone can go ahead, do some kind of study and come back with a list of things that we needed to do to support it, and just so that people have like a more of an understanding of how much of the challenge that will be, to some preliminary survey on it.
Yeah. I think G was trying to find someone who interested on this, and if we don't have any volunteer on supporting like multiple container runtime, we can draft out or decide together. And once I have time, I can put some stuff in a document. I will send a document very soon. So every time we have a chance, we can add more stuff in it. Yeah. So investigation is definitely needed for different runtime. Maybe for now we should have someone, maybe myself, to take a look on runC, see how to play with runC and see how many features, what kind of features Mesos might be interesting. I think the biggest part it is the OCI support. Let me add an action item for me. Hey, Zhitao, are you still? Do you have some comment on different runtime?
No, I think no, I don't have too much to contribute here. I think I like Jim said, I support to look into more runtimes. We have potential use cases using VM here. They were not high priority, but if there are existing plugins that we can just take off the shelf and use, we might support that to some customers.
Okay. Yeah, sounds good. We still have 14 minutes.
So actually, one thing related to the container runtimes is the Mesos executor model. Most other container runtimes don't have the concept of a executor. Like, you don't have to write an executor. So I think that's an interesting design question. If you have a third-party runtime, what happens to your executor? Where is that?
Yeah, that's a good question. So I think we could still support both case, and so make a Docker containerizer as an example. It support both way, so people could build their own custom executor, and the custom executor gonna be running inside of a Docker container. And the other way, it is rely on the Docker command executor, and the Docker command executor gonna launch the Docker container. So I think for the other container runtime, we might still have both for both case, but I am start thinking like, should we introduce more command executor? It might not be a good direction to move forward. And if you want to provide to refactor our default executor to support those runtime, that might be doable. That might be doable by the default executor, but it might make the default executor more complicated. And so yeah, maybe we could do that. So have the default executor to support the new runtime with the new containerizer, and then people could still specify a custom executor which is running as a new container runtime. So for example, the runc launch the container, so the executor running inside of that container. That's another way. That's another way to go. We could support both, I think. Yeah, you need to think about that.
Yeah, a comment I'll make is, so for people who's not that familiar with the Mesos, but have some idea about containers and even scheduling things, the concept of executor has always been pretty strange to them. Like I think from a historical point of view, when people started the first custom executors, container may not be as widely adopted as now. So there's a lot of functionality, custom runtime functionality that's better built in the custom executor. But I think as time evolved and the patterns like pod and especially patterns like pod or tasker group starting to getting mature, I think people realize more and more work can be slowly moved into using those design patterns and not to involve a very custom executor that is specifically fitting one purpose. So I'm just express some impressions that maybe sometime in the future, if there is more complex container runtimes, which I'm not sure whether people will actually be able to maintain the combination between custom executors and the different container runtimes properly.
Most of our users of custom executors date from the days before pods, and we've just never taken advantage of pods to bring those features into modern practice.
Yeah, basically Mesos does not have the concept of pod, so it is still executor based. So people launch tasks or task group inside of an executor. So I think they are, because it has been, if I on my own understanding, so they are different concept. Task and executor, they are a concept for Mesos specific. And container is another concept on Mesos. And people could run executor inside of the container, or people could have the executor running outside of the container and have the executor to launch a container.
Right. What I'm actually arguing is whether the system can be a little bit more simplified.
Yeah,
I think your system both helps operator as well.
Yeah, I understand. I totally understand that part. Because
really, task is really critical because the entire status update design and the system reliability reconciliation is solely built around tasks. People are grasping that concept very well. Container is fine because container more or less maps to its own runtime file system isolations, and it's a piece of work that's actually happening on the machine. People can grasp that concept pretty well. but the concept executor then gets pretty big there. What's it actually, what that piece of code or concept is actually doing? And actually it often have slightly different behaviors in different setups.
I feel that confusions come from people binding the concept of task and the concept of container together in Mesos, which but in Mesos they are like separated.
I think from the developers, from we who are very familiar with this code base, it's obviously easier for us to understand there is a pretty big difference here. But if you're asking how to make a Mesos widely adopted and easier to use, people started from containers. People build the image. This is what they run on the developer workflow. They say, okay, now let's map a container to a task, and then your thing will seamlessly run in the data center or in the cloud. People can understand that. But if you tell them, okay, there is actually a lot more combinations here, they will suddenly get confused.
Yeah, I think that's some of the confusion comes from like those users are Docker user or Kubernetes user. They are container based, and on Mesos, let's say I'm assuming if a new user they are using some built-in executor like command or default executor on Mesos. So our expectation is they only specify one or two things. One is what the task looks like in protobuf. Another is like they have the option to specify an executor. So if it is the default executor they want to use the built-in executor, they just need to define the task. So the task is the only user-facing concept. And for advanced user, they might want to build their own executor. So those are for some advanced user. They want to do some customization with their own executor. They want to do different things. So they need to specify executor info. And for container, I think there are those confusion comes from some legacy issue because we don't have a concept of container. Many years ago, we only have executor and task, and the task it only manage the Linux process and monitor the life cycle of the process, and then we add the SQL. So when we add the SQL support for the task, we don't have the concept of container yet. And after the SQL, when we want to add more isolations, we realize, oh, this is Linux. This is the container, and then we introduce the containerizer component. Yeah, I understand your point, Zhitao. Yeah. So you're saying like for new users, they have to pick up different concept, and for the executor, it might be confusing to them.
I think it's both for new user and a much longer term. Like like if you look maybe 1 year or 2 years down the road in the future, and if we honestly put a rank about different concepts and which things in Mesos is most important, I think to the ecosystem or the user here, container these days are honestly the most important thing they care. We also need a task, like I said, because without task and actually the important need task is the ID and the status update interface around it, so people can build a reliable distributed system using this. But executor seems like the least important concept in the stack.
Yeah, I think we could improve that in documentation, because in my own expectation for new user, we only support. We don't expect the new user to understand the executor. We only want the user to specify like what the task looks like, and then they just launch a task on the built-in executor. And we have the executor API with the agent, and those are for people who want to do some customization. For example, there are some I know there are some projects, many other projects they build like Yelp, like the Twitter, like Aurora. They all of them they have their own custom executor.
Yes, I know them, but
and yeah.
What I'm arguing is from my experience with these custom executors, I think a majority of their functionalities can be modeled through the task tendency container or task group APIs, probably. They do not necessarily need these. They do not necessarily need to model these things with a custom piece of code running on the actual machine.
Yeah, I agree. Our custom executor basically supports logging, some framework messages, and service discovery. And all those things are possible using the pods concept.
Okay, I see. So Zhitao, you mean here it is like, since we already have the task and task group, so we could have the executor concept injected inside of those two components, those two API, and then if user want to do some customization, they can still specify something inside of the task and task group.
Yes, I think what I'm yes.
Yes, and then we might have some backward compatible issues that we might have to address.
Yeah, I think there's always compatible issue. This is if we ever started with Mesos 2.0, which we can drop certain things. The first thing I'm going to start looking at is whether we can drop the concept executor there. So in Mesos, if we reach Mesos 2.0.
Yeah, I think this is something we could start to think about after we deprecate the command executor. Because I think last time when we decided the 1.6 goal, Jens, you was pretty interesting on deprecating the command executor.
I have some proof of concept patches, and if you want to look in the review board, so if anyone wants to shepherd that work, I'll be happy to go back and invest more time.
I'm very interested in reviewing those work for my own sake, so I have one few combination in my cluster.
The work is like the work for deprecating the command executor. It's straightforward. It's really not very much change. The problem is the work is like fixing all the tests.
I can help review the patches if once you have them, and because initially I've been thinking about like this might not be easy because we are running a first level container and then right now in default executor it is a nested container. It might break. I'm not sure it will break UI, and I'm not sure it will break some other things. But yeah, we could definitely achieve that at some point. Okay, we are running out of time. So Jens, would you mind to discuss the last item for 2 weeks later in the next meeting?
Yeah, sure. I'm happy. I just put it on the agenda because it's what I'm working on right now. So if you're interested, I'm also happy to chat on email or in Slack about that.
Okay. Yeah. So maybe we could check about the deprecation of command executor once you have more patch, and if you have something you would like to discuss, you can add that command executor deprecation agenda item for next meeting.
Yeah, I can dig up the review. I have it somewhere.
Yep. Okay. Sounds good. And I think that's it for today. Thanks for joining the meeting, and see you 2 weeks later.
Thank you.
See you guys.
Bye.
Thanks, Gilbert. Bye.
Bye.
Yeah.
Bye.